All right, so let's take a look at this quadratics practice test. First thing you're going to do is you're going to have to graph a parabola for me. And to find the zeros, what we're talking about here, again, is where it crosses or where it touches the x-axis. I'm going to be looking for several things on this problem. Number one, the axis of symmetry. Well, how do you find the axis of symmetry? You plug the numbers x equals negative b over 2a. You're going to use that formula and plug in b and plug in a and see what you get. You're going to get x equals negative 2 as the axis of symmetry. Here's that vertical line, x equals negative 2. Then you're going to find the vertex. How do you find the vertex? Well, you're going to plug negative 2 in for the x here and tell me what you get for y. So you're going to get the vertex, negative 2, negative 1. Negative 2 squared, positive 4. 4 times negative 2, negative 8. 4 minus 8, negative 4. Negative 4 plus 3, negative 1. That's your vertex. Then I'm going to check for your table, x and y. Since you already have negative 2 for x, also use negative 3 and negative 4, then negative 1 and 0. Plug these numbers into the original problem. Go ahead and pause the video, plug those numbers in, and see what you get. You should have gotten negative 4, 3, which would be here. Negative 3, 0. We already plotted the negative 2, negative 1. Negative 1, 0 is here, and 0, 3 is here. So I'm going to be checking for the axis of symmetry here, the vertex here, the table, overall table, to see if it's correct. The next thing I'm going to be looking for is the actual graph. Are you graphing these points properly and drawing a good parabola? It'll look something like that. Okay? And then the zeros. Where is this crossing or touching the x-axis? And that would be at negative 3 and negative 1. And there you have number 1. In number 2, it asks you to factor this. So we always look for a GCF first. Now we don't have one here, but you still always have to look. So we're going to break this up into 2 parentheses. We know that the x times x is x squared. We have to use factors of 21 that add up to 10 plus 7 and plus 3. Set each of these equal to 0. When you solve for x here, you get negative 7. When you solve for x here, you get negative 3. So the roots are the negative 7 and negative 3. Remember, the roots, zeros, x-intercept solutions, they all mean the same thing, and that's where this thing would be touching the x-axis. Here you're going to be using the quadratic formula. Well, what is the quadratic formula? Class, I cannot help you unless you write things down. If you make mistakes, I can help you out then. But if you don't write things down, not a whole lot I can do to help out. So start with your formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You pause the video and see if you have the numbers plugged in here correctly. Things I'll be checking on this problem are you following directions by writing down the formula? I will be checking for the discriminant, the number underneath the radical sign. Is that correct? Now, to show me the radical, simplified radical, we've got to ask yourself, can we simplify radical 41? If you can, you need to keep going. Since we can't simplify radical 41, this would be your answer in simplified radical form. So just bring it over here. Negative 3 plus or minus radical 41, all of it over 16. And then from here, you're going to plug these things into your calculator. Do negative 3 plus radical 41 over 16, then negative 3 minus radical 41 over 16, and you get your answer. Rounding them off to the nearest tenth, you get 0.2 and negative 0.6. Now in number 4, starting with number 4, all of these can be done using any method. Well, I don't see any graph paper, so we're not going to do that. So we're either going to be factoring them, or you're going to be using the quadratic formula. We know the quadratic formula always works. Sometimes it can get a little bit long and drawn out. So the first thing I would do, because it's quicker and sometimes easier, is let's see if we can factor this. First of all, do we have a greatest common factor? No, we do not. But I can break it down into two parentheses. I know that x times x is going to give me the x squared. I have to have factors of negative 6. Factors of negative 6 are negative 1, positive 6, positive 1, negative 6. Negative 2, positive 3, positive 2, negative 3. Those are my only combinations that I can use because I'm needing factors of negative 6. I cannot get away from that. Which ones add up to negative 5? 1 and negative 6. So I'm going to go plus 1 and minus 6. Set each one equal to 0 and solve. You get negative 1 here. Set this equal to 0 and solve. You get x is equal to 6. Either order, doesn't matter which one you put first. I have negative 1, positive 6. And number 5. It is a quadratic. You've got your x squared, right? So we need 0 on the right side. So we have to add 50 to both sides. 2x squared plus 20x plus 50 is equal to 0. See if this can be factored first. I'll tell you right now, if you can pull out a GCF, you're probably going to be factoring it anyway. Is there a GCF? Yes, there is. That GCF, 2. So pull out that 2. We've got 2 times the quantity. X squared plus 10x plus 25 is equal to 0. Remember what we did with this 2? Exactly. We tossed that because 2 cannot be equal to 0, but we do factor the rest of it. Now look what happens. I get x plus 5 times x plus 5 is equal to 0. And since we're talking about two numbers that are the same, it's pointless to write both of them down. So we just said x plus 5 is equal to 0, x equals negative 5. Now, could we have been using the quadratic formula on these? Yes, we know it always works. But if I can get by saving some time by factoring, let's do that. But if not, you have to go to the quadratic formula, which is okay. It's just that that's going to take a lot of time. Make sure you try to factor first. And if you can't find the way to factor it in the first 5 to 10 seconds, go ahead and use the quadratic formula. That's fine. But let's see if this can be factored. I have 2. It's going to have to be 2a times a. There's just no doubt about that. Now I need factors of negative 9, some combination of negative 9. You have to have factors of negative 9. You cannot put any other numbers here and here. You have to have factors of negative 9. Well, I need negative 7a in the middle. Here's how it works. If I put a minus 9 here and a plus 1 here, look at what I get here. Negative 9a. I get positive 2a. There's your negative 7a in the middle, so I have factored this correctly. Set each one equal to 0. Solving for this one, we get 2a is equal to 9. Don't stop there. We need to get the a by itself. A is equal to 9 halves. Subtracting 1 here, of course, you get a is equal to negative 1. So I've got 9 halves and negative 1. Now, the 9 halves can be written as 4.5 or 4.5. I prefer improper fractions unless I'm graphing it, but any one of those will work. X squared minus 2x minus 20. Are there factors of negative 20 that add up to negative 2? Well, we have 1 and negative 20, negative 1, positive 20. We have 2 and negative 10. We have negative 2 and positive 10. And then we have 4 and negative 5 and negative 4, positive 5. Do we get negative 2 out of any of those? No, you do not. So we are not going to be able to factor this one. So you go ahead and plug this into the quadratic formula and see what you get. Go ahead and pause the video, and I'll be back as soon as you come back. So you should have come up with 2 plus or minus 2 radical 21 all over 2, because again, I'll be checking on this number right here, the discriminant. Did you get 84 there? And if you didn't, look at what I have compared to what you have and see what the problem is. But here's what we need to do from here if we're going to give the simplified radical. And I will accept either one, the simplified radical here or round it off to the nearest tenth. Now, notice that these 2's cancel. Now, ignore the 2 radical 21 for just a second. What's 2 divided by 2? This 2 over this 2 is 1. Okay, now, put that back in, now meaning the 2 radical 21. Cancel these, and you get plus or minus radical 21. So 1 plus or minus radical 21 would be your answer. Because of this plus sign right here, this is not a difference of 2 squares. This cannot be factored. M squared plus 81 is prime, which means there is no solution. Number 9. You have a quadratic, x squared. You need 0 on the right side, so we're going to add 2x to both sides. X squared plus 2x minus 48 is equal to 0. Do you opt for the quadratic formula because you know it works, or can we factor this real easily? Well, if I put in x times x, I need factors of negative 48, which means one has to be positive, the other one has to be negative. I need more positives. How about 8 and 6? So x plus 8 equals 0. X minus 6 equals 0. We get negative 8 here. We get positive 6 here. Negative 8 and 6. Number 10, I'm going to try to factor this. What's the greatest common factor? 3. So factor it out. Not 2 parentheses, only 1. We need 2 terms inside the parentheses. When you divide out the 3, you get x squared minus 25. Again, what do we do with the 3? Yep, we can toss that. Now, x squared minus 25 is a difference of 2 squares. Remember how to factor a difference of 2 squares? We know it's going to have to be x times x, right? I need factors of negative 25, which means one of them has to be plus and the other one has to be minus. And of course, we're going to use the square roots. So we have x plus 5 is equal to 0, which means x is equal to negative 5. We have x minus 5 is equal to 0, which means x is equal to positive 5. So you can write this as plus or minus 5. Or you could go ahead and do 5 comma negative 5. Either one's fine. Now, number 11. You've got an option here. You could FOIL the left side, subtract 64 to get 0, and go from there. Not a problem. It would be factorable. You wouldn't even have to use a quadratic formula, although you could. But I'm going to take a shortcut here. Notice how we have the left side is squared. And I also have a perfect square on the right side. This makes it really, really simple. Because in order to cancel out the squared here, all you have to do is take the square root of it. Well, if you take the square root of one side, you have to take the square root of the other side. The square root and the square to cancel each other out, you're left with x plus 5. The square root of 64 is, remember, we need plus and minus here, plus or minus 8. It's at this point you need to write 2 different equations. X plus 5 is equal to 8, and x plus 5 is equal to negative 8. When you subtract 5 from both sides here, you get x is equal to 3. When you subtract 5 from both sides here, you get x is equal to negative 13. So 3 and negative 13. In number 12, you have 2 consecutive odd integers whose product is 143. On your ECA, take your highlighter and highlight these things here. Odd product, those are key things that you're going to need in order to answer this correctly. You know you're going to have a first number and then a second number, finding 2 of them, right? Well, what do you always call the first? X. Now, considering the fact that these are odd numbers, how far apart are odd numbers? 2 numbers apart. So your next one after x would be x plus 2. Now it says the product of these two things is 143. So multiply them. Take x times x plus 2. You'll get 143. There's your equation. Now, we can't do anything with this problem because of the parentheses, so we have to clear the parentheses first. Use the distributive property. X squared plus 2x is equal to 143. What kind of equation do you have here? Quadratic, right? So how do you solve a quadratic? Well, you need 0 on one side, so subtract the 143 from both sides. And now what are we going to do? Well, I would try to factor this. You know the two numbers are two numbers apart because they're odd. What two odd numbers can we multiply to get negative 143? Well, how about 13 and 11? But I need more I need more of the positive, so I'm going to have x plus 13 and x minus 11. 13x minus 11x gives you your 2x. Now, think about this. You're finding two different x's, right? Because of the x squared, we're going to have two different x's. So what's x in the first case? Well, x is equal to negative 13. Well, what's x equal to in the second case? Well, it's equal to 11. Take this into consideration. If there are two of these guys, there are going to be two of these guys. So here, when x is equal to negative 13, what's x plus 2? Negative 13 plus 2 is negative 11. So there's one set. So you're coming up with two sets of answers here. And if x is equal to 11, what's x plus 2? Well, that'd be 13. So here your other two answers are 11 and 13. So on this problem, you're looking for two sets of answers, not just two answers. Number 13. The length of a rectangle is 7 inches more than the width. The length is 7 more than the width. Width is mentioned second. Define your variable. W is equal to the width. Now, what are you going to do to find the length? Well, you're going to take the width and add 7. It's 7 more than the width. Area, not perimeter. Area, multiply. W times W plus 7 is equal to 228. W squared plus 7W equals 228. Get 0 on one side. Factoring this, what do you come up with? What are you getting? Plus 19 and minus 12. 19 times 12 is 228. 19 times negative 12 is negative 228. 19W minus 12W is 7W in the middle. So we factored it correctly. Now here's the deal though. When W plus 19 is equal to 0, that means W is equal to negative 19. We're not going to have a rectangle with a negative width, so we toss that one. Doesn't make sense. But we will get the width being equal to 12, which means the length then would be equal to what? 19. Number 14, a ball is thrown into the air. The function h of t is equal to negative 16t squared plus 20t plus 27 gives the height h. The height is in terms of h. The height is h. At any time t, so at what time is the ball 10 feet off the ground? Isn't that the height? And isn't the height h? So the height in terms of t, we're going to put 10 there. So I'm going to rewrite this. Negative 16t squared plus 20t plus 27 is equal to the height, which is 10. We need to put 10 there. Quadratic, what do you need on the right side? 0. So we're going to subtract 10 from both sides and get negative 16t squared plus 20t plus 17 is equal to 0. Go ahead and pause the video, plug this into the quadratic formula, and see what you come up with. Plugging everything in correctly, you'll get a discriminant of 1488. So we're going to round that off to the nearest tenth. Since we're talking about time, we'll round that one off to the nearest tenth. We're either going to have negative 20 plus 38.6 divided by negative 32. When you do that, you get negative 0.6 seconds. That would mean we're going back in time. I don't think we're going to do that. And then negative 20 minus 38.6 over negative 32 is 1.8. Here is your correct answer. In number 15, when you can draw a diagram, label the sides. We're going to have x minus 10 squared, because that's how you find the area of a square. Take the side and square it. You get 196. Remember how I showed you to do number 11? We had something squared is equal to 64. Take the square root of both sides. Well, we're going to do the same thing here. We have something squared is equal to 196. Take the square root of both sides to eliminate the squared. You'll get x minus 10 is equal to, remember, plus and minus 14. Write two equations. X minus 10 is equal to 14, and x minus 10 is equal to negative 14. Adding 10 to both sides here, you get 24. Adding 10 to both sides here, you get negative 4. We will toss out the negative because negative 4 doesn't make sense here. So 24 minus 10 is 14, and that works. 14 squared is 196. We will skip 16, 17, and 18, jump into 19. To clear the radical, you're going to square both sides. So you're going to have x squared is equal to 4x plus 12. You have a quadratic, 0 on one side, which means you need to subtract the 4x and subtract the 12. So we're going to have x squared minus 4x minus 12 is equal to 0. Factor it. X minus 6, x plus 2 equals 0. Set each one equal to 0. X equals 6 or negative 2. Well, think about it. If we take the square root of whatever number this is, will we ever get a negative 2? No, we can toss that number. But x equals 6 does work, so there's your answer. Now in number 20, we're going to square both sides, which means we need to square both sides, which means we have a binomial squared, which means what? FOIL. You have to take w minus 4 times w minus 4, and the radical gets cleared on the right side. W times w is w squared. Negative 4 times negative 4 is positive 16. You get negative 4w, negative 4w again. So we're going to have w squared minus 8w plus 16 is equal to w plus 2. Go ahead and solve this one out. Pause the video, and I'll be here when you come back. You should have gotten w is equal to 7 and w is equal to 2. Now, do they both work? Because on your test, you might have only one work, you might have both work, you might have neither one of them work. So you have to check your answers and see if it makes sense or not. We're going to try the 7 first. What's 7 minus 4? 3. What's 7 plus 2? 9. Is 3 equal to the square root of 9? Yes, the 7 works. Let's try the 2. 2 minus 4 is what? Let's clear this up a little bit. What's 2 minus 4? 2 minus 4 is negative 2. Are you ever going to take the square root of a number and get negative 2? No, out of here. So your answer is 7. Well, good luck on the test, and I will see you in class.